Now we're going to move on to chapter 16, 16.6. Yeah, 16.6 from your textbook, page 360. Instantaneous center of zero velocity. At the end of the lecture, the students should be able to locate the instantaneous center of zero velocity and use the instantaneous center to determine the velocity of any point on the general body in general plane motion. Okay. So the application, instantaneous center, or you say IC, of zero velocity of a bicycle wheel is at the point of the contact with the ground. Can you see here? Okay, so the velocity direction at any point of the rim is perpendicular to the direction of the IC. Now, how do you do this? How do you calculate? How do you find the IC value? Very simple. Just pay attention here. Look at this point. Where is the tangential velocity? Somewhere here, right? Okay, so what you need to do is you just need to take the ruler and you need to see a point where they actually meet. Okay, if let's say this white line, you just take a ruler and you just draw. Okay, you take this white line, you just take a ruler and you just draw a line. Take this one, 90 degrees, it has to be 90 degrees. What I meant is 90 degrees. Take a line, okay, 90 degrees, just draw. Okay, and you will see that there will be one point that it's actually meeting. So that point will be the instantaneous zero. Yeah, I'll show you another example later. Okay, well, before this, let's look at this ladder. Is it a ladder? Oh, it's a board. Okay, this is the board. Okay, now the board is sliding down. So sliding down. Okay, when it slides down, means B is coming down, A is going this way, right? So very simple. You just take a ruler, okay, you draw a straight line, perpendicular line to the bottom part of the arrow. You just straight line. Okay, and then you draw a straight line for the A. 90 degrees, it has to be 90 degrees at the base of the arrow. Okay, just draw. So you will see there will be a point that they are meeting. So this is the IC. So that's how you find your IC line. Yeah. Now, why is it important? Because when you find your IC line, you can find equations which will connect B and will connect A. So that's the whole idea of finding the IC. Okay. So for any body undergoing planar motion, there always exists a point on the plane at which velocity is instantaneously zero. Okay, where it's rigidly connected to the body. This point is called IC and of zero velocity. It may not lie on the body. Yeah, most of the time it's outside, but it's okay. You can find equations to connect them. Yeah, if the location of this point can be determined, the velocity analysis can be simplified because you can get point A connected to point B and connected to point C. So that's the whole idea. Yeah. Okay. Like what I've told you. Look, this is a body. To locate the IC, yeah? There's a lesson to locate the IC. So this is the body. This is the rigid body. Okay, rigid body. And then you have a velocity. You have object A and tangential velocity is this side. So what do? You take a ruler. Yeah, you just take a ruler and you draw a straight line. Just a straight line. Okay. Okay. Sometimes some question can have. Sometimes it wants you to connect with the outside. I mean this path here. Okay, sometimes there's another question. Yeah, example. Wait, I will see another one. Okay, this is a good one. Okay, you have point A and point B, right? And this thing is moving here like this. So this line doesn't exist. This is a line that you are going to draw. Yeah, you're going to draw. The IC line doesn't exist. You have to draw. So you just take a ruler. You draw 90 degrees here. Just draw a straight line. You don't know where is it intercepting. Okay, then you take a ruler and you connect here. You will see that this is the IC. So once you have connected, then what you do? You just erase. Oh, sorry, can't do erasing. You just erase the excess line. Yeah, you erase the excess line. So it's left with a nice line here. So this line, okay, if you see, look at that. RA stroke IC. Yeah, from A to IC, from B to IC. So with these two lines, you can actually connect in equation between A and B, which I'm going to show you shortly. Yeah. Okay. So that is the first case with another external body. Second case, within the body itself, you can find. Another one is if, yeah, a body like this. We have VB here, we have VA here. So first thing to do is My drawing is not accurate, yeah, because using the stylus is a bit difficult. Okay, you have VB here, and then we have VA here. So take a ruler, yeah, take a ruler. I told you that it has to be base to base, right? Okay, when you take a ruler, you draw base to base, alamak, it's not connecting. So where do you want to find? Now, next thing, you take the tip and the tape and you cross. So you see that's the IC. Okay. Now there are some cases where they are infinity. Yeah. You have your VA here, you have your VB here. This is not infinity. This is still okay. You take a ruler, you take the base, you draw. Like never meet only. Yeah. There's no intersection anywhere. So then you take the tip and you take the tip and you connect. Okay. You will see the IC up here. There are also like it can be more than one object. Yeah. Can you see point A, point C, point B? Everything is connected to this point. It becomes like a common point. Okay. So let's look at an example. Why is it important to actually find the IC? These are examples that you can just go through by yourself. Yeah. I'm going to look at the example in the textbook, which is much tougher. Okay. So a bit of imagination is required here, because if you don't imagine, it's going to be very, very tough. Yeah. So we have block D moves at a speed of 3. So this block D actually is sliding this way, right? Okay, then you can get confused. You say, I can't imagine how is the movement. Yeah. So simple. It's okay. Take one thing at a time. I'll guide you. Just pay attention. So D to D. So it is a straight line, right? Okay. B to B. B has dropped down here. So how will this be? Yeah, something like this, isn't it? So that is the drawing. Can you see here? VD 3. VB is actually moving this side. Okay, or it can also go like this. Yeah, VB. Okay. Okay, so now you draw an IC point. I told you 90 degrees. 90 degrees. Okay. When you draw like this, what is this now? RDIC. This would be RBIC. Okay. What else hint that you have in the question? Nothing. Only these only. 3 meters per second. That's it. Yeah. You know that this rod is actually now rotating. It has an omega. Okay. Let's solve this question. So what is RBIC? RBIC would be 0.4 tangent 45. Why 0.4 tangent 45? If you see, 0.4 is the length, right? So this is 0.4 is the length. Okay. Tangent 45. Tangent 45 is opposite over hypotenuse, opposite over adjacent. Yeah. Let me just write this to make you understand even better. So tangent 45 is actually here, right? This part here. This is tangent 45. So we have what? Opposite over adjacent. Yeah. Opposite over adjacent is RBIC over 0.4, right? Okay. So which means RBIC is 0.4 tangent 45. So you get your RBIC as 0.4. Now, how to find your RDIC? Let me just erase all this. Yeah. Can you see? Okay. So now, how to find the RDIC? This part here. You have the 0.4. Yeah. And you know that this would be cos. RDIC cos 45. RDIC cos 45 is actually 0.4. Yeah. RDIC cos 45 is actually 0.4. Okay. 0.4. So you rearrange, you get the distance of the distance for the RDIC. So you now have both the distance. Okay. Both the distance, the length. Okay. So now with that, okay. What is common? The common is omega is common for both. For B and D, the omega is omega BD. Okay. So what is omega BD? Omega BD is actually, okay, omega R equals to V, right? B equals to omega R. So what we have here? BD, which is 3, okay, equals to omega multiplied with RDIC. So with that, you can find the omega for BD is 5.3. This same 5.3 can be used at point B because it's the same rod. Yeah, same rod. Same rod will have the same omega. So can you see this? Omega 5.3. multiplied with RBIC that you have found up here, yeah, which is 0.4. So you can get the velocity at B. So if you see here, this is the importance of actually finding the IC, because IC gets this the equation to connect between the different points at B and D. Okay, so with all this value, can we solve for the next one? Okay, now we look at rod AB. In rod AB, we know the velocity of B, which is 2.12. With the velocity of B, you know the radius, you can actually find the omega WAB. Now remember very carefully, yeah, if it's a different rod, so in this case it's actually totally different rod, yeah, it is not the same rod. This rod has got the angular which is 5.3, BD is 5.3, B omega A, the only thing common between omega AB and omega the only thing that's common between this rod and this rod is the B, yeah, it's the B. Okay, omega need not to be the same, yeah, because in this case it happened to be that this is 0.4 and this is 0.4. That's the reason why the omega looks like the same value, but actually no, in real life it doesn't work that way, yeah. Yeah, the only thing that's, I repeat, yeah, just pay attention to this point here. Okay, since that it is the same rod, this rod, I'm talking about this rod, yeah, for this rod here, if you see this rod, I'm talking about this rod here, it has omega BD. Okay, so this omega BD is applicable for point B and point D. You understand or not? Yeah, because it's in the same rod, yeah. But then when it comes to rod AB, okay, omega BD is not applicable here, not applicable at all. But you have calculated the VB, so VB can be used for this rod. Okay, so it works like that. So because this fellow will have different omega, yeah, will have different omega. So okay, let's move on to the next part of the chapter, which is the relative motion analysis of acceleration. Yeah, so this will be the last part of the chapter. So at the end of the class, you should be able to resolve the acceleration of a point of body into components, into translation and rotation, determine the acceleration of the point body using the relative acceleration analysis. You remember what we did with the velocity earlier? Oops. Yeah, you remember what we did with the velocity earlier? So it's actually similar. Yeah, okay. Okay. Now application, of course, when you have to calculate the acceleration, then you have to use this method, yeah, okay. The applications is just almost similar to the velocity, but now it is just that we are looking at acceleration. Okay, I think you're familiarized with this formula earlier, and now we are going to break this component into acceleration. Yeah, so finally when you do your acceleration, this is the final formula that you need to use. Yeah, just now was velocity, right? Now is acceleration. Okay, the application is the same, but it's just that now it is on acceleration. Okay, so that is the difference. So I'm going to go into example 16.14 from your textbook, page 377. Yeah, and this would be the end of the chapter. So after the explaining the example, yeah, you just need to do the questions in the study guide. Okay, so I'm looking at example 16.14, textbook page 377. Okay, if you look at this question, it says the disk rolls without slipping and has an angular motion as shown here. So what is the angular motion? We have 6 and we have 4. We have point G and point A. So determine the acceleration at point A. Yeah, at point A. Okay, remember this omega value and 4 value is actually applicable for the G. Yeah? So what they want is actually what is the velocity, what is the acceleration at point A. Okay, at point A. So we need to find the value there. Okay, AG, okay, AG will be omega r. That's a known fact. So you get your AG as 2 meter per second. So G to A at this point here, the distance is 0.5. Okay, let me just gather some information here. At point G, the velocity, the acceleration is actually 2 meter. So now you have to find for the A. Yeah, what is the acceleration at A? Yeah, okay, RAG. Okay, now let's write the formula. AA equals to AG plus omega RAG minus omega square, alpha RAG minus omega square RAG. Yeah, so now plug in the values. So it's always advisable that you solve by vector. Yeah, do not do by scalar analysis. Very confusing. Yeah, very confusing. Okay, now let's solve the question. So AG, what is AG? Acceleration at G. AG will be 2 meter per second, and negative. Why? Because x, this side is positive, right? This side is positive. Okay, next is alpha cross with RAG. So what is alpha? Alpha will be 4k. Yeah, 4k. Okay, alpha will be 4k. And then we have RAG. What is RAG? That would be the distance here to here, RAG, which is negative J, yeah? Okay, minus omega. Omega given as R square, and RAG would be again minus 0.5J. Why is it minus? Because it's actually pointing downward, yeah, in J axis, Y axis. So when you solve all this, yeah, using your mathematical formula, when you solve all this, what you get is actually 18.18J. 18J. So that is the acceleration. So what does it mean at the end of the day? At point A, the acceleration is actually pointing upward 18 units. Yeah, 18J, positive J, means pointing upwards. So that's how it's found. So if you have this kind of equations, yeah, you have a velocity or acceleration at another point, but you can find for the connecting point. So that is the purpose of this chapter. So with that, I'm ending chapter 16. So if you have any question, please do ask me during the consultation or through the WhatsApp. Yeah, please finish up all the homework that's given and upload it on the eLearn on time. Yeah. Okay, with that, thank you.